science. Now eventually we get to Galileo Galilei. He's an Italian astronomer. And Galileo's genius was he was the first person to use a telescope for astronomy. Telescopes had been around for a little while when he started. But they were used for maybe a ship captain looking to see if there's something out on the horizon, or someone at one location trying to see something far away on a hill far away. No one had ever actually tipped the telescope up and looked at the sky. Now Galileo's notebooks still survive, still provide important details for people who need to know how the sky looked in the 16th century. So Galileo made a lot of studies: craters of the moon, sunspot, stars in the Milky Way. There were 4 particularly interesting observations he made that pertain to the heliocentric controversy. His first discovery was the moons of Jupiter. Seen here, this is the Earth's moon for a size comparison. We have Io, Europa, Ganymede, and Callisto. So he discovered these 4 large moons, and really they're only just too faint to be seen with the naked eye. If you have just a simple pair of binoculars and look up at Jupiter, you'll be able to see the 4 moons of Jupiter. However, the philosophical importance of these observations is it shows not everything orbits the Earth. Galileo, over the course of a night, was able to see the moons come out from behind Jupiter, go around Jupiter, and disappear behind it. And the moons obeyed Kepler's laws themselves. So here we have a first chip at this Ptolemaic and this ancient Greek theory that everything revolves around the Earth. So maybe they said, all right, maybe everything doesn't revolve around the Earth, but the Earth is still the center of the universe. We maybe can change Ptolemaic theory a lot, but it's still the Earth is at the center. So the picture here is Galileo's observations of Jupiter's moons. You can see over the course of a night he saw them change. They were most recently observed by a NASA spacecraft named after him called Galileo. Discovery number 2, that there are mountains on Earth's moon. He observed the moon with his telescope and noticed that there are shadows of the mountains on the moon. The moon could be the perfect crystal sphere imagined by Ptolemy. All these objects in the sky are imagined to be perfect crystal, perfectly smooth. The colorations would be like the colorations of marble. You can be smooth but still see the colors. But Galileo looked and actually saw that as the phases of the moon changed, the shadows on the moon changed. So again, this chips away at Ptolemaic theory. Proponents said, all right, maybe the moon is rough, but still the Earth is at the center of the universe. By the way, those of you who are in lab, we're actually going to measure the height of some mountains on the moon using Galileo's method, just by observing the shadows on the moon. Discovery number 3 was sunspots. Sunspots, as we're going to see, are small dark regions on the surface of the sun. They revolve around the sun on the surface of the sun, and they change shapes. And they could be large. This picture here, we could fit 3 or 4 Earths in this sunspot itself. Now, this is another proof that the celestial objects are not perfect spheres imagined by Ptolemy. In fact, it's even worse than that. It's not that it's not a perfect sphere, it's not even a solid. Because if we look at the sun, we notice that sunspots move around the sun every 25 days at the equator and every 35 days at the poles. So the only way that I can have different rotational periods at different places on an object is if it's not a solid, it has to be a liquid. Discovery number 4 was the phases of Venus. So if I look at Venus, this picture here is Venus seen through a telescope, same magnification. We notice it gets very small and very large, and Galileo could see changes in the apparent shape of Venus due to the changes in the way it's illuminated. This is a crucial confirmation of the Copernican theory, since it proves that Venus goes behind the Sun. Now, if we look at a Ptolemaic universe, remember, the center of the Venus epicycle is on this line between the Earth and the Sun. And so Venus goes around as the Sun goes around the Earth. Now, if I look at this carefully, I notice that Venus then is always between the Earth and the Sun. The backside of Venus would always be lit. You would never get a full phase of Venus. All you would ever see is a crescent phase. However, in a Copernican universe, since Venus goes around the Sun, there will be times when it's on the far side of the Sun where it would be in full phase. When it's on the near side, it would be a crescent phase. There is no way the phases of Venus can be explained using Ptolemy's model. This was kind of the nail in the coffin for Ptolemaic theory. It proved it had to be true. There's no way that we can hold on to anymore this geocentric theory of the universe. Now, Galileo also made important experiments in mechanics. He showed that heavy and light things always fall at the same rate. He introduced the ideas of acceleration and realized friction was what slowed things down. And acceleration is just the rate of change of speed or velocity. Galileo didn't ever try to connect his astronomy with his mechanics experiments. And it's going to take the next scientist we'll talk about, to Newton, to put this all together.